Hey everyone, welcome to the CSI Secret Store Community Call. Today is the May 11th, 2023. This call falls under the CNCF Code of Conduct. It will be recorded and will be published to YouTube. If you already haven't added your name to the attendees list, please go ahead and do so. Before we start off with the discussion items, I see there are quite a number of new folks on the call. So I just wanted to take a brief time to see if you all wanted to introduce yourselves.
Oh yeah, sure. I can go first. My name is Pete Bowman. I work for Akamai. I've been actually following this project for a couple of years. Just within the last, 6 months, it's gained more traction within our organization, using the driver and our own custom provider to integrate secret delivery to Kubernetes from our enterprise key management solution, which is custom. But yeah, we found it very useful. Teams are picking it up that are deploying to Kubernetes. So thank you.
Welcome.
Cool. Here I'm Gustavo. Sorry, jumped ahead of you, Martin. I'm from External Secrets Operator, here to discuss how to actually integrate both projects if possible, because we kind of both know that this is something that we want to do. It's been a while that we're trying to get this ongoing, and basically here to show a little bit the project and how I think an integration could happen.
I'm Martin Ranyard. I'm based in Berlin and working for a Viennese company at the moment. I've been following CSI Secret Store for a long time, since the KubeCon announcement quite a few years ago now. And I've recently decided to write a one-password driver, which I'll be demoing in the call in a minute.
Okay, so my name is Lucas. I'm based in Hamburg, in Germany, and I work for Red Hat, and I'm here basically together with Gustavo. I'm also a maintainer of External Secrets Operator. So we are excited to see what we can come up with.
I think I can go next. I'm Ashwin. I work for Google. I'm the product manager for Google Secret Manager, and the CSI driver project has been something that's been really important to us and something that we've been following for the past 1 year. So yeah, looking forward to it.
I can go next. This is Amit Modak. I'm part of Google, and I'm a developer on the Secret Manager team at Google. And I've been sort of working with Tommy Murphy, who was one of the original contributors of the secrets provider, and also contributed to the Secret Store CSI driver. Thank you.
Yeah. I think that's everyone. If I haven't missed anyone, please let me know.
G'day guys, I'm Scott. I'm in Australia. I'm just looking through contribution projects, and keychain seems quite interesting, secrets. So hello to all.
Welcome. Yeah, I think this is the most number of people we've had in a while, so it's really nice to have all of you on the call. Okay. In terms of moderation, I can help moderate the call. Does anyone want to volunteer to take notes?
I'll do it.
Thank you, Nick. Okay. So jumping into the discussion items, the first one is ESO and Secret Store CSI driver projects. Before I give it off to Gustavo and Lucas, I just want to say, some of us went to the ESO community call yesterday to present the CSI driver, and then we did an intro about it. So this is going to be an intro to ESO, and then our discussion on how both these projects could potentially work together. Gustavo, Lucas?
Thank you. Can I do a screen share here?
Sure. Let me give you permissions.
Thanks.
Okay. Can you try now?
Still disabled.
Okay, try now.
Now it worked. Can you see my screen? The presentation, hopefully.
Yeah.
Awesome. So this presentation is very short. It should be around 7-8 slides. The very first 4 ones will basically talk about how ESO kind of works. Why every time that we try to have this conversation, we already had one back. The last one that we had was in 2022, and we just came up with a conclusion that it would be super hard. I'll explain why that was the case. Show a little bit the new features and how we think that might be the turning point to actually make it work. So basically, ESO is also a tool to sync external secrets in providers, just like Secret Store CSI. The main difference is that instead of our interface be a volume that is getting mounted to the pod invisibly from Kubernetes, we actually sync it as a Kubernetes secret. In order to do that, we have 2 main abstractions here. One is the external secret, which is our representation of how we want our secret to look like, what is the information that we want to fetch. And the other one is the secret store, which actually relates to the provider. What is the provider that I'm trying to configure, with what credentials, with what service account, if I'm using RSA, workload identity, you name it, the bit regarding the provider itself. Regarding features, the main important ones that I want to focus here is basically on lifecycle management. So what happens if the provider doesn't have the secret anymore, or if we need to do a join from an existing secret, not really owning it, but merging it, is something that ESO already supports. This is a use case, especially if we think about Argo and Flux. Secret templating, which is the ability of only getting the secret information itself from the provider and template a more complex configuration file, and extract secrets from structured data. This one here is key for the integration as I see it, at least. So basically it's getting a JSON and convert the JSON with some manipulation into the Kubernetes secret in the end. So this is basically how ESO works. Again, the 2 basic manifests. We have an external secret with the data field here, which specifies what is the information that I want to get, and a reference to the store, which actually contains what is the provider that I want to talk about. When we discussed that in July, August 2022, I don't even recall when we actually discussed that. This was a problem because the fact that the data definition is on the external secret object means that there is no easy way to use the secret provider class. We cannot just put it here because the definition of the data to be got is on the secret provider class. This was the main problem that we were trying to face on for, I don't know, the past calls that we had it here. After that, our project recently evolved. We had 2 new groups to be added. One of them is push secret, which is the analogous of the external secret, is sending information to providers. Not gonna go into that right now. The other one is the generator API group. The idea here is that the secret store contains the information. The generators are APIs that we call and creates the secret information. So the secret, the sensitive information, doesn't really exist. It gets dynamically generated. As an example for the generator, please ask questions if I'm going too fast. I'm just trying to be mindful of time for the other people, the other agenda that we have here. As an example of the generator, we have a password generator where we define how the password is going to be assembled. This is going to be assembled in memory in ESO, in this case for that generator. And then on the external secret, what changes is that we start to have a source ref to that generator, and we don't need anymore to specify which data information we get. The generator provides every data that we need. And this is the key here, because what we can do then to actually leverage the integration for both projects is on the external secret manifest, we can have a dedicated source ref to a secret store class. This could be a new source ref or a generator. We can figure that out a little bit afterwards. And then after having that source ref, external secrets will act as the CSI client here, talk to the provider, get the information as a mount, but not really mounted anywhere, just get the outputs, and then create the Kubernetes secret. This is full imagination, okay? I don't know the code complications of that, but these are the two ways that we've personally imagined to see it work. So the first one would be a secret provider class ref, where I simply pass my provider here, and things are done. This manifest here then becomes the actual information for that bit of ESO controller to go talk to the provider, get the information, or via just another abstraction of the generator ref. From code perspective, the first one seems to be a little bit better than the second one. And the way that it would work in the end of the day, the mount response.files that the provider offers, we can actually unpack it into a map file.path, file.content. File.path is already a string, file.content is already a slice of bytes. So from a Kubernetes secret interface, we would already be compatible. Having said that, there are some issues, even from the very basic design that we already seen. The first one, the way that the driver itself communicates to the providers is via Unix socket. So this means that the deployment itself, ESO deployment, would also need to be able to do that. This means that we probably need to mess with the deployment permissions, or maybe even convert it to be a daemon set. This can be tricky. And maybe this is the biggest issue that we will need to investigate if we follow that route. The second one, if I go back here, when we do this approach, it is implicitly saying that the pod that is getting the information from the secret provider class is ESO's pod service account. So this could mean that the controller would get a lot of permissions, which is not good. But this issue could be easily tackled if we just added another bit here. Instead of secret provider class ref name, we also provide a service account ref to actually specify which permissions do we want to use when getting that. It could be a way. Third point, file path names by default are not compatible as Kubernetes secret key because of the slash, but we can already leverage some ESO, the templating feature from ESO. One of the things that we can do is do a rewriting. So we could come up with a rewrite to actually replace the path, the slashes from the path into any other keys, either specified by the user or have a sensible default for them. And the most important one here is the code complexity. Even though from an integration point of view, this seems like the perfect spot because it is kind of what we want to do. It might be a little bit tricky to actually get it off the ground, leveraging what already exists in terms of the secret provider class and its interfaces. Super fast, super, I don't know, summarized, but that's what I really wanted to show here. So now I wanted to open the space a little bit for questions.
Yeah, thank you for the presentation. So like some of the open questions that you have, I actually built a POC last night, which is exactly that. So I think the first one, the way I've done it in the POC now is it's basically the controller is a deployment. And instead of having the providers run as standalone daemon sets, I've just added them as sidecars to the controller. So basically they all share a common volume, and then the Unix domain socket is available there, and then the controller is just able to talk to any provider that's part of that single package deployment. That would also mean we have to move away from our model of where you can deploy the driver and the provider separately. Now you would have to have like a single package deployment that needs to be provided as part of every release. But that is how I've solved that in the POC. So that was the first one. And then the second one, we had the same concern during discussion. And then as part of the POC, I have the service account in the new CRD as well. So basically, when you create the new CRD, there's a service account name that you provide, which for now I just have it as a mandatory field. And then there is a reference to the secret provider class, basically saying like, hey, this is the secret provider class, which is there, and I want to use it as is. And the controller basically reads that, gets the secret provider class, and then does exactly what you actually talked about. So basically, it gets all the files as part of the RPC response, parses them, and then syncs that as Kubernetes secret. And then the files response that we get, actually, it's the name is not a path. The path is actually constructed on the CSI driver. So you can still just use what you get as part of the RPC response. So like I'll show that in the demo at the end. But basically you have the file name and then the file contents is bytes. So you can just read through those files and then use that as sync as Kubernetes secret. And the code complexity one, I completely agree because as I was writing the code, it was just like crazy. I was moving things around and it was a lot. But I agree on that one. Sorry, go ahead.
Generally speaking, around the POC that you did, the only point that I think we could probably improve is because for me, the most valuable thing about these discussions is on these types of enterprise clusters that they need to have secret store CSI driver for the application code, but they also need to have external secrets to do all the COTS or cloud native projects that depend on Kubernetes secrets, that it's part of the platform tooling that they have. So in that sense, if we install the provider twice, kinda is a little bit contradictory for me. In that use case that I have in mind, have 3 installations, one for external secrets, one for the driver, and one for the provider class, and make them all work together. It's what it will be key. Again, imagination only. But yeah, it's good that at least the problems are the same, right? It means that we're working towards a actual solution here.
Yeah, I think the sidecar model would only come in if they don't want the driver to be running on the node. If like their only use case is to sync as Kubernetes secret, then we just need to provide a different way that all of this is packaged. But otherwise, it could work. But the only thing is now this controller deployment, like ESO or the POC, would depend on some other component to exist. And then if that thing gets uninstalled, then basically like your custom resources go away and like a couple of other things goes away. So like we still need to provide like a packaged version that would work standalone. But if that exists, trying to leverage that would be fine. I think Mo has his hand up.
So one thing I was thinking about in this is, so if such an integration existed, would it be confusing to users if the behavior of a secret store CSI driver provider behaved differently than the equivalent ESO built-in provider in some subtle way? Right, so I think ESO supports AKV, and obviously Secret CSI Store supports AKV, but they're not the same code base, right? I mean, they're probably very similar, but they're not exactly the same, right? So that could be confusing if, say, for example, we add like extra like policy mechanisms in the AKV Secret CSI Store provider, and then the customer is using ESO and expecting it to behave exactly the same way, but they don't realize that they're not referencing like the right magic strings in their YAML to make it go through the CSI interface effectively, or the UDS style provider approach. Does that make sense? My concern making sense there?
It does. Generally speaking, and here is very long term and totally based on my opinion. Don't take it as, I don't know, the project's opinion or whatsoever. That would really only be solved if we even joined more efforts to unite the 2 projects and eventually have only single definitions for provider classes altogether. which is something that from a community point of view makes sense in my opinion, but it is indeed a lot of effort. On ESO, we're kind of already indirectly looking at that because we are trying to get away from in-tree providers as it is. Even if we have out-of-tree that we ourselves maintain, we are still looking at out-of-tree providers just because from a security point of view is a lot of code that people need to have just to install ESO. And we want to reduce that. From the very beginning, I don't think we have a way to escape this confusion in the sense that there will be a time that both code will exist.
The problem about uniting this is like, it's basically breaking changes, right? For both.
That's why I said very long term.
Yeah.
There are a lot of problems that comes out of it, but in terms of an idea, it's not an absurd to think of. Again, in terms of an idea.
Don't take this as like an opinion or even really as a direction, but mostly as a thought exercise. Like, I don't think anyone really has issues with like Windows, Mac OS, and Linux existing, even though they technically solve exactly the same problem, right? Which is orchestrating like shared CPU usage across processes without privilege escalation effectively, right? Is it really bad in our CNCF, Kubernetes overall community to have two projects that do the same thing in slightly different ways? Like I don't like it. To me, I don't personally see us as competing. We're just solving the same problem in different ways. I feel like that is like I kind of get that kind of story maybe being said, and I don't know if any of us actually feels like that at all.
Yeah, I agree a lot. I think the main drive for us to pursue this is like the requests from users to do something in this regard, to be honest.
And
not only
indeed,
users, but like some.
Yeah, and even if we think about having those, the main thing that started this discussion actually is because a way to do secret syncing CSI secret store side exists, right? So basically, can you not leverage what already exists in the community? That's really the point that we're trying. I'm kind of being the salesman here, just because we kind of already know some use cases when people are syncing external providers into Kubernetes secret. And these are already by default plugged into external secrets resource. So that's the, I don't know, win of it.
Okay, Martin has his hand raised.
Yeah, for me, it's almost the opposite. So I gravitated to CSI secrets driver because the secrets don't exist in Kubernetes in the API. You don't have to lock the API down. But what I would see as a huge benefit is being able to use the same provider, the same driver in both things. So the Azure driver, the Vault driver is as a driver for either secret store CSI or external secrets. That's where I would see a benefit, because you have less copies of code doing exactly the same thing. That's where I would see the benefit. But personally, I didn't use secrets, external secrets operator, because I don't want the secrets in the API.
And just to echo what you said, Mo, the very point that I made to Rita when we were on KubeCon is to actually just see if there is ways that we should integrate or if not. So the very conversation is, the very first thing that I wanted to ask is, do we really want to do that? Maybe we don't.
Yeah, I don't have an answer to that. And I'm sorry, I think I got there late. Like I think you and Rita were talking and I showed up like right as you had to leave. So I'm sorry. I meant to sync up with you guys, but I'm glad you got to at least speak with Rita for a bit. But yeah, no, I have been personally struggling with this question. I think probably the entire time I've been at Microsoft, because it's been basically discussed since then, I think. Though, by the way, Anish and folks, I do appreciate all the effort put into like trying to see how to make all this work in a collaborative fashion. So I really do appreciate that. What do folks feel like would be a good next step?
We started a document last time, but I think we were a bit lost on what to write on the document and like push it forward. I think now we have a few more ideas. Maybe that makes sense. Start throwing away, like brainstorming some things on that document. Maybe even like pros and cons, like we are talking about here. Like, does it make sense to even do this? Oh, what do you think?
In terms of the Secret Source CSI community, who I think we do need, I think in terms of technical bit, we could just take your POC, Anish, see how we could actually just leverage it minimally to support that secret, the source ref bit on ESO. That would minimally prove the value, right? Even if we go for other design decisions afterwards that are more complicated and we need to spend the brains. But before or in parallel with that, we kind of need to understand from both communities if that's what we want to do, right? So maybe having a document with pros and cons, and then just going ask our community if we should or should not. That should be it, right? Because in the end of the day, we're just, I don't know, people representing a bigger thing.
Right. Yeah, before I go, like I think Anjali has a hand raised.
Yeah, hi, I'm Anjali. I'm a product manager in Red Hat. So I'm really interested in seeing both these projects work together. If you're starting a common document, maybe we can start by adding use cases where it makes sense from a user workflow perspective. Where would it make sense to have a sync for the secrets and where it wouldn't? So maybe that can be the starting point for your design.
Yeah, yeah. In my opinion, I think that's a good idea to start a doc so that like we can. I think so. We know the approach that we want to go down is a controller approach. I think like the question now is, do you want to like make use of ESO, the generator that Gustavo shared, or do we have a standalone controller, right? So I think we can list those options in the doc, and then like Lucas mentioned, like add the pros and cons, and then also like add the use cases. And I think once we have the doc in a state that we can share, then maybe we should share it with the wider community, right? Like, or maybe on issues or something, so that we can solicit feedback from the users from both projects and see if this is what the general consensus is. And then we can make a decision on that. So that's what I think too. Mo?
So just thinking sort of through this doc, like I feel like at least for Secret CSI Store, right, like the decisions we make here are probably pretty dramatic and important for the long-term sort of like next set of things that we do for the project. So I'm kind of thinking that, certainly we can probably make like a GitHub issue and everything, but I'm also thinking like, if anyone's used the Kubernetes docs recently, you can't go to any page without that giant red banner on the top saying that the registry changed. And so it's like kind of impossible to miss. I kind of feel like we need to do the same thing here, that it can't just be like a Slack message and a GitHub issue. It like kind of needs to be into your face all the time for like next little bit, because foundationally, I think what we're saying is like, we need more input from the people that use our stuff to see what's beneficial to them. Like for example, like I'm trying to start like a conversation with Signode about maybe having some support for environment variables that I could shove in using secret CSI stores. So you didn't need to mount a secret just to stick it in an environment variable, because that's what your app needs, right? Those types of things, right? Like, so really trying to reduce the need for Kubernetes secrets to places where you actually need the reference for like an ingress controller or something, those types of things. But, I want to make sure that it's not just like the few examples that we've seen internally that are leading me to that conclusion. Does that make sense? Does that resonate with folks?
Yeah, I think the use case definitely resonated with me more, especially the secrets for the ingress control.
Yeah, and I agree on the banner stuff. Like, I think like that's the way that like when users go look at it in the main README and all of that, like they can go and provide feedback. Like I think once we have the doc in a state where we think we can get feedback, I think we should definitely do it.
Yeah, I agree.
Okay, so in terms of next steps, we can like one of us can start the doc and then start adding details there. That's all good. Okay. Yeah. Thank you so much for joining the call and presenting it.
Thank you for having us.
Thank you for having us.
Okay, so the next item in the agenda, Martin has a demo for the 1Password provider. Martin, do you want to share screen?
Sure. Yes, please. And I will try sharing the whole screen. Apologies, because I want to switch between browser and terminal. So with abject apologies to literally people on this call, what I have done to create this driver is rip out some of your wonderful code and put in my own. So I found the docs for building a provider somewhat sparse. It's a bit of a difficult task, but so what I did was I took the Google Cloud Platform GCP driver and ripped out the Google stuff and put in some 1Password stuff. So this repo will go away, and I will create a separate repo under the company name fairly soon. But I wanted to show it because it's super cool. One of the interesting things that came out of it is the way that the flow works for 1Password. So 1Password provide a thing called 1Password Connect, which sits in your cluster, which acts as basically a caching proxy so that you don't hit rate limits, and also so that you're only authing inside your cluster. So it auths with 1Password. So there's actually 2 tokens here. So that's just a bit of a thing there. The diff is not that big. I mean, I've deleted some of the stuff, and the code is very much the Google code, with just some of the 1Password stuff added in here. So yeah, 1Password Connect Go SDK rather than the GCP one. I will also say, for those who know the setup, I've actually still kept it saying GCP because I'm not quite sure how to make the CSI, the Secret Store CSI driver part have a new string in there. So I've symlinked the socket into gcp.sock in my installation. And this was, I'm a manager, not a coder these days. So this is sort of a day's worth of manager code, so please don't judge that. But if we have a look at my setup here, in the standards places, we have the CSI Secret Store driver as installed by the Helm chart. As I say, I've symlinked the socket. CSI, come on. Oh, come on. Yes, I know I must. So oh, anyway, I've symlinked the socket in this pod, and that's kind of working. Not really touched that other than creating that symlink. But what I do have, if we go to my code, is we have under the templates, the only real changes. I haven't actually pushed that. Did I push that? The where's the? It's under examples, isn't it? Sorry. The app secrets. So I went with the. I'm really like, this is really hacky code, so please bear with me. But what I've done is I took the GCP idea here of vault/vault name and secrets/secrets and used the 1Password IDs, which I have committed because, again, hacky. But in 1Password here, you can see the vault ID and the item ID, and yay, security. So if I switch to, oh, and before I do switch, in my test namespace here, we have 1Password Connect, which is, as I say, that proxy server that sits inside your cluster that you auth to. And that actually has a secret, which is annoying because you have to have a 1Password auth token for the Connect driver to talk to 1Password, and also for the driver as well. But if we go to the demo, in here, I don't have a secret, which I like, which is good. But if I exec into, apparently I can't type today. Exec into the pod here. This one doesn't have bash. IT Martin. And we ls var secrets, and we secrets new 1.txt. So again, I'm not sure what to do in terms of how to, because you can access an entire secret item, or you can access a field within. So I literally JSON encoded for now. I welcome to hear feedback on what the best practices here are and what other operators are doing if they're doing this. But that way you can actually get the label and value of the field. And also, if we go to new 2, that is just the password value, as I showed in the resource name here. So the resource name here doesn't have /password and does here. And that is basically it. All I've done is ripped out the Google code, put in the 1Password Go SDK, and connected it to this 1Password Connect, which is the proxy server. But it seems to be working. there is no sync again. If I change the password here, it doesn't change until I delete the pod. I don't know, again, whether that's a feature that is normally existent in CSI, because this is the first time I've actually used it in Anger. But it's super cool and it's working in my development cluster. I'm going to use it in my home lab. I'm going to, as I say, I'm going to take this fork, republish it under the Meister company account and properly open source it, clean up some of the docs is my next step. But yeah, that's it actually working in my cluster. So yeah, I guess that's about it. Open up to questions and discussion. Thanks.
Yeah, this is really great. So I've got 2 points. Like, I think one was I'm glad you mentioned about the docs not being sufficient enough for building a provider. I think I would like to work with you to like go through it and see how we can improve that. Because I think more and more providers are implementing it. So like the more easier we make in terms of documentation or any examples that we can provide, I'd be happy to do that. And then the second one was to answer the question that you had, where you said you updated the secret, but you didn't see it get updated in the mount. So we have this feature called rotation, auto rotation. It's not enabled by default. So like it's something that you can turn on with a feature flag. And if you do that, the CSI driver will periodically check if there's a newer version of the secret that you have mounted and then go and refresh.
Oh, nice, nice. Any opinions on the JSON blob for like an entire secret item versus the fields in it? Because that was just like instinct. I'll chuck it in JSON.
Yeah. So at least for the driver, some of the providers provide an option where you can parse like the JSON and extract individual values from it. Like for instance, Vault provider does it, and then I know recently AWS had a feature request, so they did submit it. They did that too. But yeah, like they store it as a blob, and then basically the provider can parse through the JSON and then extract only the required fields for you and pass it back to the driver. And then drive the today, like the driver also has the sync as Kubernetes secret feature. But there were certain requests for that as well. They were like, oh, can you parse the JSON and just take one field and put in the secret? There is a PR open from Dane. Like I think that's also up for discussion next, which is called transform options, which can parse through it and then basically like take only the required fields and put in the Kubernetes secret.
Super cool.
Anyone else have questions for Martin?
Again, apologize for ripping out your code, because I know that someone in this call has written some of that code that I've deleted.
Yeah, thank you for the demo. That was really cool.
No problem. Thanks.
Okay. The last one on the agenda is has anything changed since Tommy's feedback? Pete, is this you?
Yeah, yep. This is it. Yeah, and you just gave a brief overview of this feature of this transform operation that takes the content returned from the provider and it can use JSON path to break that up into multiple different files. Those files could be, I guess, mounted in the CSI volume or synchronized to a Kubernetes native secret.
Right.
Given the comment earlier, I think the use cases for this are mainly around the native secret, but it could also apply to volumes. I'm not sure on that, but I didn't know if this was a direction the project still wanted to go in supporting.
Right. I mean, I think if we split it out, then this would just go into like a separate controller, like a whatever route we go down with. But at least in terms of where this current PR is, in some of the previous discussions, Tommy did mention like the feedback that he had on the thing. And I think Tommy was going to pick up this PR, and he's been playing around with doing some of these transformations using Cell. And I think at some point he might be able to demo it, but we can follow up with Tommy to see if he's still doing it, and then see what the next steps are in terms of that.
Okay, that's good to know. I mean, there's pretty actionable feedback in this PR to take it with the JSON path, but if we want to go Cell instead, that would be good to know.
Yeah, and unfortunately, Tommy couldn't make it today, but we can start a thread on Slack and then follow up with it.
Okay.
Yeah. But thank you for bringing it up. Okay. So I think we've run through the agenda items, so I can quickly show the POC that I had. Oh, can you still see my screen? So yeah, like I mentioned before, so like I built like a controller which has a new custom resource that can be used to reference a secret provider class. Like I wanted to do a ref, but for now I just wanted to build something simple. So like this is what a sample looks like. So this is a sample. So like this is like a new custom resource which just says, hey, I want to use this only to sync as a Kubernetes secret. And then, like I mentioned before, this one demands that you have a service account name, because at least in terms of all the providers that we have, there could be like service account tokens, so workload entity. So like right now there's an explicit check saying like, hey, if you don't have a service account name, I'm going to fail. And then the service provider class name is basically the user reusing their existing secret provider class without any changes. So like whatever they have today, they have it. And all they do is in this new custom resource, they say like, that's the name that I want to use. And all of this is namespace scope, like it doesn't go across namespace. And then this key I added because today we support rotation on the driver. And then the rotation, the pole interval is configurable only on the driver level, which means you don't have flexibility per secret provider. And I think with the sync controller, we have the option to do that, like if we do it. So you can have different rotation pole intervals for different Kubernetes secrets that you sync. So that is what this is. And the token request is basically very similar to what the CSI driver object has today, where you can tell kubelet which all audiences you want a token for a particular service account. And if you have multiple of them, it'll just give you an array of it. And then you can choose which token you need to use to be able to get the secrets from the external secret store. So like it's some of the existing things, basically like consolidating that in a common resource. And this is my secret provider class, which hasn't changed for this controller design or any of it. Like it's exactly the same that I use for the CSI driver as well. So this secret objects is what tells the controller that like, hey, I want you to sync those things as Kubernetes secret. So like the secret name is going to be foo secret. And then one of them is secret 1, other one is secret 2. And then in the Kubernetes secret, I want the keys to be foo and bar. And also this was the deployment model that I talked about. So in this case, I have the custom resource. And then in the single controller deployment, like I have sidecar containers. So one of my containers is the actual sync controller that's going to be doing the sync as Kubernetes secret. And then the second sidecar container is right now I'm testing it with provider Azure. So basically that's the Azure provider that's running as a container, and they all these containers just share a single volume. So like the Unix domain socket is available to the controller if it has to make a call. And let's see. If I get so yeah, so I already created my secret provider class, which exists, and this is what I showed before. And then the next thing I'm going to do is just apply the secret provider that I shared. And once that is done, basically the controller here goes and creates the Kubernetes secret for you. So basically it says like, hey, it's created it, and then it's queued for next rotation. And if we get secrets, so there is a foo secret, and we do a get over YAML, so it synced this Kubernetes secret, and then we can see that it was created by the secret store controller. So this is, so I haven't made any changes to the provider. Like I'm reusing the provider sidecar, the container as is. So like I haven't touched the provider at all. The only implementation for this POC was the controller, which also has minimal code only in this section. The rest of it is, I was able to reuse most of the CSI driver code. So like this controller is where most of the logic goes in, but rest of it is all coming in from the CSI driver. Like some of it I've imported, like some of it I needed to modify, so I just entered it in.
Did you push this to a repository?
Yeah, it's all in my private fork now, but I can make it available. Yeah, I'll make it public, or I'll probably give anyone interested access so that you can look. But this one is complete, so I'll just add examples here and share it.
Yeah. Yeah, it's very like not similar, but close to what Gustavo was thinking about in a way. Yeah. Yeah, and this is being recorded and this will be uploaded to YouTube as well, right?
Yeah.
Okay. Cool.
Anyone
Yeah, I need to check a bit more on the deployment strategy that you're using there, but yeah. And then I think we can start the document from that. It's very interesting. Yeah.
Yeah. Anyone else has comments, thoughts?
So is there any approach where we could have out of tree providers that aren't UDS based? I'm just kind of thinking through. I guess the only choice there is then like gRPC or HTTP, right? Like you basically have to have a, or maybe wrong. Maybe I should just say TCP, right? Like something over the network instead of local. You get into the whole like, well, how does the controller authenticate to these things, and like, how do you secure that tunnel? Where do you keep the secrets for that tunnel that you're trying to not have in Kubernetes secrets? It gets really messy very quickly. And you get to kind of cheat with the UDS because you're like, it's all local, and you would have to be root on the kubelet to do anything with that UDS. So I don't know. It does make the deployment model kind of icky for the controller though, because it's totally fine when the driver and the providers are separate on the kubelet with the daemon set approach. It's less easy to reason about how you're gonna, like, I don't want the CSI controller thing to be like shipping everyone's providers shoved in the YAML, right? Because that was one of the explicit things, like when SIGAUT accepted as a project, that we would not make secret CSI store kingmaker, right? Anyone gets to have their own secrets. We're just building an interface to let you get them there. So, but this one,
I think that is where like Helm really helps. Like if it's all like a single manifest, yeah, then it becomes really hard. But at least for the driver, so far we've been following this model where if you want to be added as a supported provider, there's like a basic E2E suite just showing that the provider test pass and stuff like that, right? So like that could be one criteria where if you are a supported provider, you could basically add to the Helm chart with like a conditional saying like provider and then enabled is false by default. And then like it's a single Helm chart and then the user can deploy it. And then the provider stays in the Helm chart as long as like the E2E tests are passing on a regular cadence. But yeah, like having it in one deploy manifest, like right now I don't have Helm charts or anything. And then it's just one provider. Like that YAML will keep growing if we just keep adding more and more providers. And as a user, you won't get to pick which provider you want. Like you will basically end up with like some 8 or 9 sidecar containers if there are like 8 providers. Like it's just a bulky pod.
And they will surely fail intermittently.
Right.
I mean, you could have if statements around all of it, right?
If it's a static manifest, no. Like then they will have to use some kind of like external tool to like msubst or something which will do all of that for them.
Yeah.
But yeah, if it's just like a static one, then they'll go apply and then it's boom, 10 sidecar containers.
Yeah, that gets really messy.
This is the only time I'll say that Helm will help here.
Yeah. I think in need trouble. This is like a safe word. He's actually in great duress right now.
I mean, one alternative to the whole networking a UDS would be some kind of sidecar that did network to UDS, like, and do off there somehow. I mean, it like if you've got service mesh, you've not got so much of an issue because you can really lock it down. But yeah, anything that gets networky starts to get auth problems. Even with a sidecar of some kind, it's gonna be really hard.
Yeah, and also like I think with the POC, the thing was mostly like how can we make it run without provider making changes. But yeah, like the UDS thing definitely helps there. Like it just makes it a lot easier.
Yeah, I think no matter what, you get stuck with at least one secret somewhere, or one secret per. And I know we're over time, but like one secret per provider, because you could theoretically authenticate the driver to a provider using service account tokens. So you could make that work. But that means you have a TLS connection. And so there would be a public key on the driver side, and that's fine. So that's easy. But then on the provider side, there has to be private keys that are signed to complete the TLS, right? And that's where it becomes hard because there's no way to have in a default Kubernetes installation a guaranteed mechanism to be able to provision some kind of certificate, right? Yes, service mesh and all these places give you opinionated versions of that, but there isn't a default one. And again, if you're using secret CSI store and you want to be very careful about which secrets exist in where, like you will be like, well, yeah, I want the serving certificate of that provider to come from my secret store. And you'll be like, but how? It is the secret store. Like there's a circle in your dependency graph. So.
Before we drop off, Lucas, I know you mentioned in ESO, you're looking at splitting the providers. Like, has there been initial discussion? Like, has there been any thought on how the controller would come?
It's still very initial. We didn't like have like a design doc or anything like that yet. So it's just, we know that we need to do that. And we wanted to do before we announced like the official GA, because we want to be feature complete and some other stuff, but this is one of the things that we want to have as well. But like, we didn't have like the design discussion yet. Yeah.
One thing that might be worth bearing in mind, that it's not necessarily the secrets provider that's going to write the provider. Sorry, that was really difficult to pass. But for instance, I have zero affiliation with 1Password, but I have been able to write a 1Password driver, and therefore it's really accessible. Whereas if it has to come from the provider, in this case 1Password or Azure or whatever, then it becomes a much harder step.
Okay, I think we're 5 minutes past time. So this is a really good meeting. Thank you everyone for joining, and we have a couple of action items, so we'll follow up after the call.
Thank you.
Thanks, everybody.
Thank you.
Bye.
Thanks. Bye.